My name is Michael Loubier. I started working in rapid prototyping last year, actually kind of on accident. Growing up, I always fiddled with this kind of stuff, and it's kind of crazy to see that some of this stuff has kind of just expanded so much in the last few years. So the first question people have, of course, is what is rapid prototyping? Rapid prototyping, if you Google it, it's a lot of people, they've got CAD software and they generate a model and they either 3D print it or they CNC it out. And that's what rapid prototyping has been for a long time. But now with the technology as modular and as simple as it's become to get full microcontroller, microprocessor packages into a simple, affordable device, you're now seeing the ability for us to generate and create electronics rapid prototyping, which is kind of what I'm doing. So the idea is very simple. You take a concept, you make it real, and you keep it simple. So you take the idea for a design. So for example, I have a product up here. It was a level 1 prototype I worked with the gentleman on. It's just a simple counting device for exercise routines. It's very simple. You go on, you click on it, you want 5 sets of 10, and you want them to be 2 seconds long. And you click go, and it counts for you. It has a buzzer, lets you know there's audio feedback and visual feedback. The idea being, at the time, was to get it into like physical therapist's office. That idea pivoted and changed quite a bit since then, but the fact of the matter is that I was able to take that idea, create an electronic prototype of it, and it took about 2 weeks, which is something 10, 15 years ago, if you want to create an electric prototype, you go through a team of investor or a team of research and development department, something like that. It's not something you just go to the hardware store, I want a microcontroller, and you slap it together. The cool thing is you've got things on the market like Arduino, Raspberry Pi, and there's a new one actually coming out that Michael showed me. It's going to be, they project as about $9 a unit, which is really cool. $9 a unit is way down even from Arduino, which is about 40 or 50 depending on which unit you buy. So at $9 a unit, you could create, hardware cost-wise anyways, you could create a prototype for $30, $40, $50 maybe. Product cost, or materials cost anyways. Why use it? The big thing is people a lot of times will have big ideas. I have an idea for, this will be the next marketable thing. This is going to be the next, Google of ideas. And they have the idea and they think about it, they play with it in their head a little bit, and then it goes poof and it disappears. Or they talk to investors, they go to companies like InventHelp or something like that who want money to help them create that product, and they never get beyond that phase. The cool thing is with these new technologies, you can really segue into that manufacturing stage without having to start at a really expensive product. In that first example I used, for example, we talked on that prototype, we talked to a few manufacturers who were really interested in the product, and because we already had a working model to put in front of them, it really just exponentially lowered the cost that we would have had to invest to get that to a full manufacturing level. We're talking hundreds of thousands of dollars off the price it would have cost us to get it to that level. So it's a big deal to spend, again, materials cost-wise, $70 to $100 on the parts that we had there, and of course, my time, to save $100,000 or more. And it's cool too because these custom solutions are not just for a prototype. So our idea, that example is very, it's kind of a complex electrical idea, but you can take this into other fields. For example, I saw online a project that a gentleman passed out. He's got, code is open source, it's available for everybody. It's automated irrigation for his garden. Very simple idea, costs about $50 in hardware. It's got a light sensor, moisture sensor for his soil, and some PVC pipe with a couple of holes poked in it attached to a garden hose. That's it. It calculates the moisture in the soil, it calculates the sunlight, and it waters his garden for them. Apply that in areas like Valpo, for example, and you could have an automated garden outside your house that you don't have to mess with. And oh man, I'm just so busy today, I can't get it done. Okay, fine, it's watered. You're done. So it's not just in this field of people hear electronics and kind of get scared away. It's not just that. You can really make it simple enough for somebody in agriculture who doesn't want to mess with that kind of stuff to really enjoy that product. The thing is, it's new enough that it's not really been explored in a commercial setting, which is kind of neat. The only company I know of that really does anything like this would be InventHelp. From what I've read, their initial investment required is $50,000 to begin a project. That's a huge investment for an idea that you're not really sure has any marketability yet. If, for example, like I said with the automated garden, if that's just something you wanted personally, I wouldn't spend $50,000 for an automated garden. That's a lot of money. Or, theaters, for example, I talked to some people at my little brother used to do some plays at Chicago Street Theater, and me and him were talking with a few of their people, talking about how cool it would be, you know, oh man, how cool would it be if I could build you guys this thing that made, you know, your costumes light up in these weird designs and stuff like that. And that's so easy to do with this technology that it was just something that is just never would have been heard of, you know, 20 years ago. And again, as quick as it was, that first generation prototype, which I'll pass around, I'll show you guys how it works. It's really easy. It took me about 2 weeks to make. Very quick, very simple. As you get past that into more advanced stages, things do take longer, but you know, depending on what you're looking for, these prototypes can be developed in just a matter of weeks, sometimes even less. Again, the point being that this technology, you know, 10 years ago, if you wanted a prototype, it takes a lot of resources, it takes quite a bit of time, and it's just not feasible for the average person to just say, I have an idea, let's make it happen. But nowadays with technologies like Arduino and Raspberry Pi and, you know, all the new devices that are coming out on the market, it's really extraordinarily simple to find some way to create any idea and make it happen. You can even use open source platforms like Android, for example. I'm actually working with a prototype right now that we may be porting over to Android because it might simply be easier to use their existing hardware to make that interface. And these things are all available. They're very customizable if, you know, you have the programming knowledge to do so, to make a product that really can, you know, change somebody's whole life. And hopefully with the same technology, you'll see just a huge boom in innovation. I mean, that's really what we're here for. You know, if I can make an idea, and even if it's just for me, if it makes my life easier, that's great. That's a huge thing. If I can make, you know, Jack over there, if you've got a problem and you really want to just, you know, count golf balls or something, do it. It'll cost, there's hardware for it. If it makes your life easier, great, you know, or if, you know, whatever it is, if it makes your life easier and it's worth a little investment, we now have the technology to make that so simple for you to go from that concept to that reality. And that's pretty much it. I've got some stuff here. I actually have, if you guys want to take a look, I don't know if we have enough space for it, but like I said, I've got a couple of 3D printers and a 3D scanner if you guys want to take a look and see how that kind of stuff works too. First thing I've got here, this right here is the entire brain of a 3D printer. That's it. You load some software on there, you hook it up to the hardware, it's a 3D printer. You take that same software, you change it up a little bit, it's a CNC machine. Change it up a little bit, you've got a laser cutter. You just switch out the parts. I literally have a kit that I built. It cost me about $300 to build a 3D printer, and that's all it is. And I can switch out a few parts there, and like I said, make it a CNC machine, make it a laser cutter, make it, you know, anything like that. That hardware is there, and I'm even amazed at how cheap some of it is. It's incredible that we are able to get this type of technology for, you know, just you know, go back 30 years and try to make a computer that small. That's literally all it is, to be the brain of that. This right here is actually the work in progress of one of the prototypes I'm working on right now. The same one I'll show you. This is the latest version of it. Much larger screen. It's actually gone to a desktop. Is actually kind of what we're going for. This unit will actually be able to record audio, playback audio, such as for counting the exercises for you. It'll record greetings, birthday messages, congratulations messages, so that when, you know, for example, the idea being is we can give this to your grandmother, and when if she's working with a physical therapist and the physical therapist says, hey, I really need you to do 5 sets of 10 of, you know, just raising your arms every day for the next week. Chances are, and what we found talking to the home care specialists, that oftentimes people don't do those exercises, but if I can give you a personalized reason to do that, if I can put your grandkids' voices on here and say, hey grandma, great to see you, can't wait to see you again, I hope those exercises are going great, your chance of doing those exercises goes up exponentially. I mean, it's pathos, which is, you know, it's a strong emotion. You would get that emotional response, but also the hardware is pretty neat here. It's also going to be functioning as an alarm clock and several other things as well. So if you guys want to take a look at that. This is a very rough version, of course. The idea being that you can take this, I can look at all the hardware that goes into that, strip it down to the parts that I need, strip away the superfluous things, build a custom board, and have a pre-manufacturing prototype ready, and take it before an investor or a manufacturer, and I can significantly reduce the cost needed to actually get to that manufacturing level of the product. And even, you know, with all of this hardware being modular like that, I could, for example, if you wanted to do market research, if you wanted to see how people actually respond to these things, which is what we did with the original version, I built 5 of them. We put them out in the field, we let people try them out, they really liked them. What it came down to is that insurance agencies are very slow about adopting new technology, and so while that idea is still there, it may be a very long time before anybody comes around to say, oh, we should put these in there. So even though the people on the floor, on the ground level, are excited about it, it's hard to get it to them if the bigger, insurance companies and things like that aren't on board. And what we found is that even with really great ideas, the insurance agencies sometimes take a very long time to adapt. So we've just kind of been moving the product forward into different phases. And that's what we have here. And like I said, I built 5 versions of that one. We gave it to people, let them try it out. They loved it. Great. We got some market research on it. We found out what they loved, what they hated, and what features they were requesting. And one thing they requested was audio. I was able to add that. It took me about 3 days. Or actually, it took me about 2 days to get audio actually functioning on the device to beep, count, and do all that would help these people with their exercises. I've also got a couple things here. These are kind of silly things that we had 3D printed out while testing some 3D printers. The first one is my little brother's creation. He found it online. It is 10 Batman in a hot tub. So just kind of silly. The other is a little bit nerdy. It's a 20-sided die. It was just like I said, testing the 3D printers. I actually I help a school in South Bend repair their 3D printers as they are having some issues. Right now I've got 2 more printers and a 3D scanner that I'm repairing for them right now. So this is, all of this, being able to help them with this also is really cool. They've got everyone from, I believe they go from grade 6 and up, working with 3D printers and 3D scanners and CNC machines. That's an incredible opportunity for these kids. That's great, and I love to be a part of that. This one here is just an example of, this was my little brother's idea actually. My little brother wanted to get my mom something for Christmas, but he wasn't sure what to get her, so we actually sewed in an LED strip here, and the battery actually came detached. But you can see this piece here is a full microcontroller. That little piece there can control a full array of functions and systems, mathematical calculations. It can keep track of programming. So for example, what this unit does when it functions, and like I said, the batteries have fallen off, but when it functions, there's actually a button that you can press to switch colors. And even if you hold that button, you can actually switch it to actually flash different colors too. So something very simple. My little brother paid for the materials. The material cost on that, I think, was $60, including the scarf. And again, it's very simple, but just take a look. That's a full microcontroller. That is incredible to me, that we have more processing power than a computer did 10 years ago right there.